Hello, pre-calculus class. In this video, we're going to start looking at polynomials, and specifically polynomial division and zeros of polynomials. We'll take a look at the graphs of them, but this whole next few weeks, we will be looking at polynomials and just kind of exploring them a little bit. So just to recap, polynomials you learned about in Algebra 1, hopefully, right? If not, for sure, Algebra 2. But a polynomial is anything that has, right, it's a function with x's as your variable. Some key things, the exponents here have to be whole numbers, right? They have to be positive integers. They can't have anything negative. It could be 0, right? This could be x to the 0 here. But they need to be whole numbers, no fractions, no negative numbers. And the coefficients have to be real, which you would probably assume anyway. It doesn't have to be a whole number like all of these are. I can have negatives, I can have fractions, I can have square roots, like have root 2 out here, but exponents need to be whole numbers. So we're going to do a little practice with division of polynomials. We're going to say, hey, I want to take this polynomial, this cubic polynomial, and divide it by this thing, x plus 4, right? And so when I do that, what I'm really looking for when I do that is I'm trying to find, right, like what's the quantity, like if I did x plus 4, what's the quantity that I would have to multiply this by times what, right, would give me x cubed plus 2x squared minus 9x minus 4. Right? That's the process that I'm trying to do when I do division. Right? And you've done this before with, back in middle school with just large integer values, right? Like, how would I do 5,739 divided by 4, and you do this whole long division process, right? What you're trying to do when you do that, right, anytime you're doing division, something divided by something else, is I'm trying to figure out, right, what times that thing I'm dividing by would give me the original number, right? Like if I do 5739 divided by 4, saying like 4 times what would make that value, right? 8 divided by 2 is 4 because 2 times 4 makes 8. Right, so we're just doing that with some larger values here, and I might do a little video that kind of walks through that just right, as a recap. But for now, we're coming back here and saying, how would I do this? How would I do this polynomial long division? Right, so we set it up the same way as what we would do with just normal numbers. I have the thing in the denominator I put on the outside of this kind of box here, and I have x cubed plus 2x squared minus 9x minus 4. And I'm trying to find, right, what times x plus 4 would give me this, right? So again, just like when we do with numbers, you kind of think of all of these as like your places. Like this up here would be the x cubed place. This here would be the x squared place, the x place, and the numbers place. Just like this, if I do it with my numbers over here, this column is the thousands column. This is the hundreds column, the tens column, and the ones column, right? This doesn't have thousands, hundreds, tens, ones. It has x cubed, x squareds, x's, and a number column. So I'm trying to figure out what times this would give me this. And we always start on the left, right? I want to create this biggest thing first. And I'm actually going to do this kind of side by side here, right? I want to show you explicitly, right, that how I would kind of think about this a different way. So if I have, we'll just draw a little line down the middle here. I'm trying to find x plus 4 times what is equal to x cubed plus 2x squared minus 9x minus 4. So the first thing I would need to do is say, if I'm doing x times something to get an x cubed, that needs to be an x squared leading term in this other factor, right? This other piece here, right? So if I do this, right, we put that x squared in the x squared column here like this, and then I actually do the multiplication, right? X squared, if I wanted to do that, I would need to actually do the x times the x squared and the 4 times the x squared, and that would create an x cubed plus a 4x squared. And so in this long division process, we write the same thing, right? I have an x cubed plus a 4x squared is what I have created. Okay, now I know I want to get to 2x squared. Like that's my end goal here, ultimately what I'm trying to do. And I just created a 4x squared with this piece that I've already introduced, right? The x squared times x made the x cubed. I've crossed that off my list. I don't need to get any more x cubes. I've got the one that I want. But in doing so, I also created a 4x squared term, which is 2 more than what I want, right? Like I only wanted 2x squareds. I made 4x squared. So the next thing I do has to be, right, I need to kind of get rid of 2 of those x squareds. I need to do something that would create a negative 2x squared, right? So to do that, right, I'm really thinking I'm trying to take away this. This is what I've already done with this x squared. So what I have left, x cubed minus x cubed is 0. I'm done with the x cubes. 2x squared minus 4x squared gives me negative 2x squared. This is the next thing I need to try to create. Right, the next term I need to introduce in my other factor, this other piece that when I multiplied it by x plus 4 would give me the cubic, right? The x cubed plus 2x squared minus 9x minus 4. Right, so to create that, right, I need to make a negative 2x squared. This next piece would need to be negative 2x because x times negative 2x will make negative 2x squared, right? And I'll do it over here too. It has to be a negative 2x in the x term, right? It would make a negative 2x squared here, right? But I can't, when I do this multiplication, I'm not just doing the x times that, I also am doing the other piece that I have, this 4. So I have 4 times negative 2x is negative 8x, right? 4 times negative 2x is negative 8x. Right. So I wanted there to be negative 9x, and I made a negative 8x with this next term that I put in here, right? So that's good. I'm 8/9 of the way there, but I need to figure out what I have left to do, right? I need another piece here. My next thing would need to be a minus x to create the negative 9x that I want, right? So if I look at what I've done so far, right, I've got my x cubed here, right? This is taken care of, right? This here, the 4x squared and the negative 2x squared, those combined to make the negative 2x, or sorry, the positive 2x squared that I wanted, right? The next pieces, the negative 8x and now this negative x, I made a negative 9x that I wanted, right? This piece here that I had left over, right? So I need that to be my next piece. So I need that to be my next piece here, and I can show kind of why if I just do this subtraction, right? If I subtract this, let's do it with red, right? If I get rid of this term, negative 2x squared minus negative 2x squared makes 0. I'm done with my x squareds. But negative 9x minus negative 8x, negative 9 plus 8 gives me a negative 1. Right? And so I'm trying to create that as my next thing, and maybe I could put in, right, drop down that minus 4. I'll do the same thing with the, right, this is the minus 9x, kind of drop that down there. Right? So to get that minus x, right, the last part that I need to do is this needs to be minus 1. Because if I did x times negative 1, that will make the negative x, right? So this has to be a minus 1 because negative 1 times x will make my negative x. But I also have to remember, right, negative 1 times 4 gives me a negative 4. Same thing here. I have to do this. Negative 1 times 4 gives me a minus 4. And that's what I wanted, right? And I do this subtraction here. I get a 0 remainder. Negative 1x minus negative x is 0. Negative 4 minus negative 4 is 0. All right, so I get this perfect factor here. And so what this is telling me, right, there's a few different ways I could write this, right? I have two different, right, things this is telling me. One is that x cubed plus 2x squared minus 9x minus 4 divided by x plus 4, this is equal to x squared minus 2x minus 1, and I have no remainder, right? It's a perfect factor. It goes in evenly into that, right? Another way I could write this, right, I'll do my little 3 dot therefore thing here. Another way I could write this is that, right, x cubed plus 2x squared minus 9x minus 4 is equal to x plus 4 times x squared minus 2x minus 1. Those two things are synonymous, right? I found this, like x plus 4 times that would make this piece here, right? So this tells me some good information about the polynomial that will be really helpful for some later things, right? So if I know, right, if f of x is this, right, this tells me that f of x must have a 0, right, or x-intercept. Oh, that's a fun spelling of 0 there. It has an x-intercept at x equals 4, or x equals negative 4, excuse me, right? Because x plus 4 is an even factor, right? And if x equals negative 4, right, negative 4 plus 4 is 0. And so if x is negative 4, negative 4 plus 4 makes 0 here, and 0 times anything will be 0. So I know that that is 1, 0, 1 x-intercept of my polynomial function, right? If I look at that here, right, there I go, right, my function f of x here, negative 4 is one of the zeros of that function because it's a factor, right? So what we now want to do is, if I found that, right, the next step would be to find the other zeros, right? That's kind of the natural next progression here, and what a lot of the questions that you'll see in the book will be like, right? So to find the other zeros of function f, right, we want to find the zeros of that quadratic factor here, right? We'll find the zeros of the quadratic factor right, the x squared minus 2x minus 1 piece, right? Because if this is 0, right, if the value of this is 0, then 0 times that will be 0, and that will be another place where the y values, the function values, are 0, which would be an x-intercept, right? So let's do a little, right, if this isn't factorable, it turns out, so we'll do the quadratic formula here. We got x equals opposite b plus or minus the square root of b squared, negative 2 squared is 4, minus 4, a is 1, c is negative 1, all divided by 2a. So x equals 2 plus or minus the square root. Negative 4 times negative 1 is going to be a positive 4 here, so it's going to be 4 plus 4, gives me the square root of 8. My radicand is way too long, but that's all right. All divided by 2. Right. So I get x equals, let's split this up. I got 2 over 2 plus or minus the square root of 8 over 2. The square root of 8, I can rewrite this, right? The square root of 8, I'll write that as 4 times 2, all over 2. So I get 1 plus or minus rules of square roots. I can split it up like that. And the square root of 4, right, that's just 2. So this gives me my kind of simplified answer here, is that 2 root 2 over 2, but those 2's can just cancel out, and I get x is 1 plus or minus, those 2's cancel, plus or minus the square root of 2, which, if I did that with my calculator, these are the exact values, right? root 2 is like 1.414. So 1 minus 1.414 would be negative 0.414, or x equals 2.414, 1 plus 1.414. Right. If I go here, I got my two zeros, right? Those are the approximate values. Exact values are 1 minus root 2 and 1 plus root 2. So I wanted to show just the factors on Desmos here quick too. Right, if I go back here, I had my factors were x plus 4 and x squared minus 2x minus 1, right? I wanted to find where this was 0, and I know that it's equal to this times that, right? So there's my 1, 0, where the blue is crossing, and where the quadratic part, that quadratic factor is 0. Right? There's all of my zeros all together. So that is all for finding the zeros of polynomials.